now we have another figure. In this figure we have a pipe. This is a pipe in which fluid is flowing with velocity v, right, and this tube is further connected to some pressure measuring devices. When this velocity at point A, what is the velocity? Velocity is v. Velocity is v. Now at this point B, since this point B is inside this tube of this shape, then everywhere these molecules will keep moving with velocity v, but at point V what will happen? This velocity of the A molecule will be retarded to 0. Here velocity will be 0, right. So at point V we will have the stagnation pressure or total pressure. Stagnation pressure or total pressure. So this total pressure is measured by this pressure measuring device, which is say P0. P0 is designated as a stagnation pressure or total pressure. But P0 will be the stagnation pressure in the condition when the velocity is retarded to 0 isentropically. But since there will be some loss, so that's why the pressure at B is little less than the stagnation pressure because of some energy loss, and that energy loss is converted into basically heat energy, right. So if pressure is not fully converted because of non-isentropic situation, then this device will measure little less pressure than the stagnation pressure situated at point B, right. Now we can write the relationship between static pressure and stagnation pressure in comparison to previous figure. In this figure at this point A and B, if we apply Bernoulli equation at point A and B, then we can write this equation. At point A, what is the total energy? Total energy is P over rho g. Pressure energy per unit weight, pressure head plus kinetic energy per unit weight, V square divided by 2g plus z. This must be equal to the total energy at point B. At point B, what is the pressure? Pressure is P naught divided by rho g. This P naught is a stagnation pressure and this P is a static pressure at point A, right. We have to keep this thing in mind. And what is the velocity here? Velocity is 0 and potential energy, since it is situated on same horizontal line, so z. So z can be cancelled, and this equation, which is Bernoulli equation between A point and B point, can be written in this manner. Total pressure at point B is equal to static pressure at point A plus dynamic pressure at point A, right. So by applying Bernoulli equation at point A and B, we can write this equation. This equation is derived with the help of Bernoulli equation at point A and B. Now if we solve this equation, then velocity may be written as 2 P naught minus P divided by rho, and P naught minus P is what? P is equal to W into H, because we have studied that pressure can be written in terms of the head of the fluid, right. So P is equal to W into H. W is the weight density, and this may be written as rho g. Similarly, del P may be written as rho g delta H. So P naught minus P is rho g H, right, and this H can be measured very easily, and with the help of this H, which we can measure, we can find out with the help of this equation V is equal to root of 2gh. Now this V is equal to root of 2gh is developed under very ideal condition, when we have not considered any loss. If you consider some loss, in that case we have to use some constant. And so in that case the theoretical velocity will be little more than the actual velocity. So to get the actual velocity, V is equal to some constant C multiplied by 2gh. With the help of this, we can find out the velocity at any point, right.